When you look long enough at the night sky, patterns begin to emerge. Some are simple, some are deceptive, and some are so precise that they force you to rethink everything you thought you understood. When the early tracking data for 3I Atlas arrived on my screen, I didn't react immediately. I've spent decades looking at orbital paths, gravitational curves, long period comets, hyperbolic intruders, but as more data points populated the trajectory map, something began to feel intentional, not in the science fiction sense, but in the mathematical sense. The projected path of 3I Atlas was unlike typical interstellar debris. It didn't skim past our system the way Oumuamua did. It didn't dive inward like 2I, Borisov. Instead, it was carving a very clean, very calculated arc, one that intersected a spot in space most objects do not approach with such precision. A region exactly at the radius where Jupiter's gravity begins to dominate the local neighborhood of the solar system, not close to Jupiter, not near its orbital path, but exactly at the distance where the Sun's grip weakens and Jupiter's takes over. To an astronomer, that is not a trivial number. That is not something a random comet drifting for millions of years through interstellar space is expected to hit within a fraction of a percent. When I first mentioned this, I received messages telling me it was coincidence. Coincidences happen, of course. But patterns deserve attention. What I realize, what I continue to emphasize is that precision is information. And when an object from another star system demonstrates it, we should pay attention rather than dismiss it. Let me explain why this matters. Our solar system, like every gravitational system, has regions where one body's influence transitions into another's. For Jupiter, the dominant sphere of influence begins at a well-calculated radius. The fact that 3I Atlas is headed directly into that region is in itself unusual. But what made me pause was the level of precision required. For 3I Atlas to hit this exact gravitational boundary, the object would need to arrive on a very specific angle with a very specific velocity and maintain that course for millions of years across interstellar space without being perturbed significantly by dust, stars, molecular clouds, or past stellar encounters. Astronomers often treat interstellar objects as debris thrown out by chaotic processes, planetary collisions, gravitational scattering, star formation events. These are messy ejections. They do not produce objects that arrive inside another system at the perfect gravitational transition point of the largest planet. This is what scientists call a low probability event. Not impossible, just improbable enough that it deserves inquiry. And science advances precisely when we investigate improbable events instead of sweeping them aside. In a recent press briefing, NASA presented a confident conclusion that 3I Atlas is just a comet. I take no issue with confidence. Confidence based on the right data is healthy, but confidence that overlooks anomalies is not scientific humility. One of the clearest anomalies visible in the very images they showed is what looks like a beam-like structure emerging from the object in the direction of motion, not pointing away from the sun. For a natural comet, outgassing vents produce thrust opposite the sun's direction due to sublimation of ices heated by sunlight. Solar irradiation causes jets that point roughly anti-solar. 3I Atlas is doing something else entirely. The structure is linear, directional aligned with its forward motion, and inconsistent with natural sunlight-driven sublimation. To me, this is not evidence of artificiality, it is evidence of the unknown, and the unknown is valuable. I suggested, and I'm simply stating a possibility here, that such a beam could theoretically act as a micrometeoroid clearing mechanism, removing small particles in its path. Natural? Engineered? We don't know. But dismissing the beam simply because it is inconvenient to established models is not how science should operate. This is why I've written repeatedly about the importance of data-driven conclusions rather than authority-driven ones. Many people ask me the same question. If 3I Atlas were meaningful, wouldn't it head toward Earth? The answer is no. Earth is not the most important gravitational landmark in the solar system. Jupiter is the most massive planet, the most influential body besides the Sun, a gatekeeper that controls the flow of comets, the primary sculptor of long-term orbits, the body that shapes stability in planetary systems. In every planetary system we've observed, the largest planet plays a central role in gravitational architecture. If an interstellar object, particularly one carrying mass far larger than Oumuamua, wanted to study a system, map gravitational gradients, deposit materials strategically, or simply passively drift through a stable region, then Jupiter's influence zone would be the place where those dynamics become most interesting. Let me be clear. I am not claiming intent. I am pointing out physics. When 3I Atlas passes exactly through this zone, it allows the object to potentially release fragments, adjust trajectories subtly, interact with massive gravitational perturbations, or change its long-term interstellar path depending on what happens near Jupiter. Natural or artificial, this location is strategically relevant from a physics standpoint. This alone is worth scientific attention. After 3I Atlas passed perihelion, astronomers detected something unusual: non-gravitational acceleration. Oumuamua had it too. It was one of the reasons I argued that the sunlight pressure might have influenced its motion, possibly due to a thin sail-like geometry. In the case of 3I Atlas, the change is smaller but present. And here's where the anomaly deepens. The deviation is in the direction required to make it reach Jupiter's sphere of influence precisely. Not approximately, not loosely, precisely. This implies one of two things. One, natural outgassing happened to push it exactly where it needed to go. This is extremely unlikely because random outgassing creates random pushes, not precision steering. Two, something about the internal structure of the object allows for controlled or directional mass loss. Still natural but unusual, perhaps a pressure chamber, layered materials, or irregular heating. 3. Or there is some form of engineered influence, active or passive, that creates subtle trajectory corrections. I am not asserting option 3. I am saying that science must keep all possibilities open until the data eliminate them. We do not get to choose which explanation is comfortable. We only get to choose whether we follow the evidence. I often remind people that our species is young. We have existed for a cosmic blink. Yet 3I Atlas, whatever its origin, began its journey billions of years ago, long before humans, mammals, even dinosaurs. So when we talk about Jupiter's gravitational lens, or its timing, or the object's mass, we are not talking about a modern encounter between civilizations. We are talking about dynamics written into the fabric of cosmic time. What matters is not whether the object is natural or artificial. What matters is that we are finally building the framework to treat such events not as curiosities, but as opportunities for discovery. We have instruments capable of tracking faint anomalies. We have global networks to coordinate observations. We have theoretical frameworks open to revising old assumptions. And we have the humility, if we choose to exercise it, to learn from nature's surprises. The universe does not send objects for our benefit, but it does give us events we can learn from if we pay attention. And three, Atlas, heading toward Jupiter's gravitational sphere, showing beam-like forward features, deviating slightly from expected paths. These are nature's way of telling us, look closer, because the next object may pass nearer, the next may be clearer, the next may carry evidence we cannot deny. We are witnessing the early steps of a new scientific field, interstellar archaeology. And like terrestrial archaeology, its discoveries begin with anomalies. So why does it matter that 3I, Atlas, is heading exactly toward Jupiter? Because precision is a message, even when unintentional, because anomalies are opportunities, not inconveniences. Because science must value the uncomfortable data points most of all. And because in a galaxy as old and vast as ours, an object that began its journey long before humanity existed may still have something to teach us about the worlds that came before us and the civilizations that may lie beyond us. For now, we watch, we measure, we listen, and above all, we remain humble enough to admit that the universe is always ahead of us.